Example 1.19 extends from our previous one, however this time having to derive first. So this derivative of f of x is going to require us to do the product rule. So we've got the product rule because we have two functions containing x that are multiplied together. So listing out our variables, we're going to have u equal to negative x take 2 squared and v equal to 2x plus 1. The first is going to be needing to use the chain rule because of the function within the function. It shouldn't be too complex because the derivative inside the brackets is going to be just 1. And the derivative of the second is just going to be 2. So from that information we can go ahead and derive dy dx using the derivative of the first times by the second plus the first, which becomes a negative because of the minus out the front of that x, times by the derivative of the second, giving us that. Now the purpose of our next step is to draw a sign diagram. So to help with that, we're trying to identify firstly any vertical asymptotes. In this case there shouldn't be any because we don't have a fraction, or our x-intercepts. So to help us with that, we're trying to identify where that function is equal to 0. So that will be made a lot easier by simplifying the equation. If we look closely, we can see that there is a common factor in both of these terms. So if we were to take that common factor to the front, we would be left with negative 4x take 2. And in the second term, we would have take 2 lots of the second set of brackets of x take 2. Again, neatening that up, x take 2 as a common factor, negative 4x take 2, take 2x plus 4. Finally, x take 2, we're going to have negative 6x plus 2 as our derivative. So now we equate that to 0, and using the null factor law, it will give us our two x-intercepts, x equals 2 and 6x equals 2. So we have our two x-intercepts. They're going to be the key values that go into our sign diagram. So again, trying to come up with a reasonable scale. We're going to identify by substituting numbers in between these regions what our result of the gradient or the slope would be. So the easy one would be to put in 0. If 0 is in this set of brackets, we would have negative 2 times by positive 2, we end up with a negative result. The number between our two values of 1 would give us negative 1, and in this case a negative number, so a negative times a negative gives us a positive. And lastly, putting a large number of 10 in, we would get a positive number times by a negative number, so resulting in a negative number. We can check that if we were to go back to the original equation in our graph menu. Double check our equation, draw the curve, and we can see that there is a maximum with the slope, the gradient of that line being negative, the gradient of this section being positive, and again negative. So we've drawn a sign diagram. When we're looking at part B where our graph is increasing and decreasing, we are trying to introduce the set notation. So our function is increasing. For x values, we'll use set notation. We have 1/3 is less than or equal to x, which is less than or equal to 2. And if we're looking at the decreasing sections, that is where the slope is negative. We have x is strictly less than or equal to positive 1/3, or x is greater than or equal to 2. So increasing and decreasing functions based from our sign diagram.